Hello dear students, welcome to the discussion NCERT line by line questions. Today we discuss the chapter dual nature of radiation and matter. Chapter number 11th in the 12th physics. Okay, moving to the questions. First one, work function depends on. Work function of a metal depends on the nature of the metal, then nature of surface only. Nature of surface. Both metal and nature of surface. This is the answer. Here metal only incorrect. Nature of surface only incorrect. Only. That's why. So both metal and nature of surface. Okay. That is the work function of a metal. What is work function? Is the minimum energy, photon energy required for the ejection of electrons from the metallic surface. Clear? Yes. The next one. Saturation photoelectric current increase with increase in plate potential, etc. Plate potential. See, we have the graph between plate potential versus photoelectric current. Okay, photoelectric current versus plate potential. While studying the photoelectric effect, we have drawn such graphs. At a particular intensity of the radiation, we have the shape of the graph like this. Clear? As potential increases, photoelectric current also increases. Reaches a maximum value. This is the saturation current. Okay? Yeah. So, saturation photoelectric current increases with increase in plate potential. That is the first option. Is the answer. Okay? Yes. The next one. Monochromatic light of frequency 6 into 10 power 14 hertz. Frequency 6 into 10 power 14 hertz. Okay. Is produced by a laser. The power emitted is 2 into 10 power minus 3 watt. The power of the radiation is 2 into 10 power minus 3 watt. The number of photons emitted per second by the source is dash. The number of photons emitted in 1 second is how much? We have the power is energy by time. Basically, energy by time. And the energy here, suppose there are n photons ejected in t second, then the total energy on the surface, hitting on the surface, is NH nu. Clear? H nu is the energy of a single photon. Suppose there are n photons are ejected in t time, then what is the total energy is n into H nu divided by the time. This is the power. Okay. Here n by t. See, n by t, that is the number per second. That is asked here. Okay, n by t is how much? That is asked. N by t is equal to power divided by H nu. Power divided by H nu. That's it. If you have given the power and frequency, then you can find out how much photons are ejected per second by this formula, that power divided by H nu. Okay. Power value is 2 into 10 power minus 3 watt. By H 6.626 into 10 power minus 34. This is Planck's constant. H into frequency is given 6 into 10 power 14. 6 into 10 power 14. Okay. Yes. See, this one 10 power minus 34 into 10 power 14 is 10 power minus 20. 10 power minus 20. Then here 10 power minus 3, that is 10 power minus 17 in the denominator. 10 power minus 17 in the denominator. That is to the numerator is 10 power 17. Okay. This is 2 divided by 6 into 6, 36. 36. Here is 0.6 there. 36, then 39, 40. In that range, it becomes 40 in that range. Then 10 power 17. Clear? 2 divided by 40 is 1 by 20. 1 by 20. Clear? 1 by 20. 1 by 20 into 10 raised to 17. Okay? Yes. Now, this one, we can multiply this with 100. Then here it becomes 10 raised to 15. 100 by 20 is 5. 5 into 10 raised to 15. 5 into 10 raised to 15 is the answer, option A. Understood? Calculation is very simple. The equation is also simple. Okay? Yeah. Moving to the next one. A particle is moving 3 times as fast as an electron. A particle, the velocity of a particle Vp is equal to 3 times of the velocity of an electron Ve. Okay? Yes. Now, the ratio of de Broglie wavelength of the particle to that of electron is de Broglie wavelength ratio. Wavelength of the particle divided by wavelength of the electron is 1.813 into 10 power minus 4. Clear? The particle may be dash. What is a particle? This is the question. What is a particle? Proton, deuteron, alpha and tritium. Okay? See. What is the de Broglie wavelength? De Broglie wavelength lambda is equal to h by p. De Broglie wavelength lambda is equal to h divided by p. P is the linear momentum of the moving particle. Okay. So this is equal to h divided by mv. Okay. Here lambda is inversely proportional to mass into velocity. Clear? Then lambda p divided by lambda e is equal to inversely proportional to mass into velocity. Means me divided by mp into ve divided by vp. Clear? Yes. Lambda p by lambda is given 1.813 into 10 power minus 4. Okay. 1.813 into 10 power minus 4 is equal to me by mp. me divided by mp. me divided by mp into ve by vp. See, what is ve by vp? Is 1 by 3. ve by vp is 1 by 3. Isn't it? 1 by 3. Okay. ve by vp, look into here. ve by vp is equal to 1 by 3. Okay. Yeah. Then what is me by mp is equal to 3 times of this one. me by mp. See, me, we get me divided by mp is equal to 3 times of 3 into 1.813 into 10 to the power minus 4. Clear? Yes. Then mass of the particle is to that side, then this one to this side. Mass of the particle. What mass of the particle is to the next slide. See. We have me by mp. 3 into 1.813 into 10 raised to minus 4. Then mp is equal to me divided by 3 into 1.813 into 10 raised to minus 4. Okay. Yes. What is mass of electron? Mass of electron is 9.1 into 10 power minus 31. Mass of electron is 9.1 into 10 power minus 31 kilogram divided by what is this? 3 into 1.8. Okay, that is 5.4 in that range. 5.4, 5.45 in that range. 5.3 into 1.8 is 5.4. So this is approximately, I am taking 5.4 into 10 raised to minus 4. Okay, yes. Then 5.4, 9 divided by 5.4. 9 divided by 5.4, see what we get? 9.1 divided by 5.4 into 10 power minus 27. Isn't it? 9 divided by 5.4 is approximately 1.67. 1.6 in that range into 10 power minus 27. That is the mass of proton or that of neutron. which are almost the same. Mass of proton and neutron are almost the same. This is almost 1.6 in that range into 10 raised to minus 27. So here in the options we are having proton is there. Okay, proton and neutron will not be there in the option. See, because their mass are almost identical. So here the answer is proton is the answer of the question. It's a very simple comparison. De Broglie wavelength. Lambda is equal to h by p. Understood? Okay. Moving to the next one. An electron microscope uses electrons accelerated by a voltage of 50 kilovolt. Clear? Electrons are accelerated by a voltage of 50 kilovolt. 50 into 10 raised to 3 volt. Okay. How does the resolving power of this electron microscope compare with that of an optical microscope which uses yellow light? Comparison of resolving power. You know, resolving power is inversely proportional to the wavelength of the light used. Wavelength of the radiation used in the microscope. Resolving power. Resolving power is inversely resolving power Rp. Inversely proportional to lambda. Clear? Yes. Then the resolving power, what is this one? How does the resolving power of this electron microscope? Resolving power of electron microscope divided by the resolving power of the normal compound microscope, the resolving power of the optical microscope. See, optical microscope, that is the normal one we use in the laboratory, the normal one in which we are using the light. Okay, this is equal to lambda of yellow light divided by lambda of the electron. See, this resolving power is inversely proportional wavelength. Then here that of electron microscope divided by that of optical microscope, then this wavelength in the numerator. Yellow divided by that of electron. Clear? And the lambda of yellow, we can take it as 600 nanometer. 590, 600 in that range. Okay. Then lambda of the electron, this electron is accelerated by this much voltage. Electron is accelerated by this much voltage. Then what is lambda is equal to h by p. You know, lambda is equal to h by p. See here, I may use this one. See. Then what this resolving power in the first case divided by resolving power in the second case. Okay, electron microscope to the optical microscope is equal to 600 nanometer divided by, and now we find out the lambda of the electron which is accelerated by how much voltage? 50 kilovolt. Is lambda is equal to h by p. Then this is h divided by linear momentum. How we convert it in terms of kinetic energy? Linear momentum P is equal to root of 2mk. Isn't it? P, linear momentum P is equal to root of 2m into kinetic energy. Okay, root of 2 into mass of the particle into kinetic energy of the particle. Studied it, right? Now, kinetic energy of an accelerated charged particle starting from rest is charge into potential difference. Q into V, charge into potential difference. So, this is H divided by root of 2meV. Okay, H divided by root of 2meV. And this much quantities instead of V, the rest of quantities are constants. H, Planck's constant, 2, then mass of electron, then electronic charge. This much are constants, will be there in all equations. And the only thing which varies here is the voltage applied. Voltage applied. Understood? So this one we can calculate. See, this much quantity we can calculate. That will be 1.227 nanometer divided by root V. Better we by heart it. 1.227 nanometer divided by root V. Okay. Then here we just apply the voltage value 50 kilo. 50 kilo here we apply. Okay. That's the easiest way. So here this one we get lambda of the electron. Lambda of the electron is 1.227 nanometer divided by root of 50 kilo. 50 into 10 raised to 3. Understood. Then this one, 10 raised to 4 into 5. Root of 10 raised to 4 is 10 raised to 2. And root 5 is approximately 2. So this one becomes approximately 200. 1.227 nanometer divided by nearly 200. Nearly 200. This is the lambda of electron. Lambda of electron. Clear? And this is 600 divided by, I can put this one, 1.227 nanometer divided by 200. 200 to the numerator. Nanometer is cancelled. Nanometer is cancelled. Okay. Then 2 into 6 is 12. Okay. 1, 2, 3, 4. This is 10 raised to 4. Divide by 1.227. Okay. This data 12 by 1.227 nearly 10. Nearly 10. 10 into 10 raised to 4. This one is approximately 10 raised to 5. Isn't it? Yes. So the resolving power of the electron microscope is 10 raised to 5 times greater than that of the optical microscope. This is the greatest advantage of the discovery of the wave nature of electron. Electron, such a small particle having a very, very small wavelength. Okay, if it is true, means if electron is having wavelength, then we can use it in the microscope. Okay, and microscopes are based on the wave nature of the radiation or matter. Okay, and the resolving power is inversely proportional to wavelength. Since electrons having very, very less wavelength, the resolving power will be so much huge. The resolving power of the electron microscope is 1 lakh times. This is 1 lakh. 1 lakh times greater than the resolving power of the optical microscope. That is the greatest advantage of the discovery of the wave nature of electron microscope. By using the electron microscope, we can investigate the internal part of cells, etc. Okay? Clear? Yeah. Moving to the next question, number 6. A particle is dropped from a height h. The de Broglie wavelength of the particle as a function of height is proportional to. When a particle is dropped means its initial velocity is 0. It is accelerating downwards due to gravity, and when it travels a displacement h downward, the square of its velocity is equal to 2gh. We studied. Here de Broglie wavelength is asking. De Broglie wavelength depends on the speed, and square of speed is 2gh. So speed of the particle in free fall starting from rest is root of 2gh v is equal to root of 2gh. Okay, and we have de Broglie wavelength lambda is equal to h divided by p. P is mv. Okay, de Broglie wavelength lambda h divided by mv, which means lambda is inversely proportional to 1 by v. Clear? Which means the wavelength is inversely proportional to root h. You know, speed is proportional to root h. Clear? So lambda inversely proportional to root h means lambda is proportional to h raised to minus half, isn't it? Root h is h raised to half in the denominator. To the numerator it becomes negative. The power becomes negative. H raised to minus half is option 4. Okay? Very easy question. The next one. A proton and a particle are accelerated through the same potential difference. The ratio of de Broglie wavelength lambda p to that lambda alpha. Actually, this is alpha. A proton and an alpha particle. Okay, this is alpha. Okay, change it here. Alpha. A proton and an alpha particle are accelerated through the same potential difference. Potential difference for these two charged particles applied are same. Okay. The ratio of de Broglie wavelength is dash. See, de Broglie wavelength we studied h divided by p. P is root of 2mk. Root of 2mk. And the kinetic energy acquired by a charged particle, if it is started from rest, if it is accelerated through a potential difference V, is Q into V. Kinetic energy, Q into V. Okay, yeah, Q into V. This is equal to H divided by root of 2mq into V. This is lambda. Clear? Now in this question, H is same for both proton and alpha. Then mass is different, charge is different, potential difference is same. Potential difference is same. So in this question, lambda proportional 1 by root of mq. Okay, 1 by root of mq. And now the ratio to be calculated is that of proton to alpha particle. Proton to alpha particle. Lambda of proton divided by lambda of alpha is equal to, see, inversely proportional root of mass into charge. So root of inversely proportional. So here comes proton first, then here mass of alpha divided by mass of proton, then charge of alpha divided by charge of proton, because inverse proportionality. Clear? Now what is mass of alpha particle? You know alpha particle is helium nucleus, isn't it? Helium nucleus, which means there are 2 protons and 2 neutrons. 2 protons, then 2 neutrons. 2 plus 2, 4, mass number. Clear? Then what is mass of alpha? Mass of alpha is twice of mass of proton, because there are 2 protons, plus twice of mass of neutron, isn't it? Yes, twice of mass of proton plus twice of mass of neutron. See, mass of neutron is approximately nearly equal to mass of proton. Slight difference only. Understand? So this is 2mp plus 2mp approximately. So 4mp. So mass of alpha particle is 4 times of mass of proton nearly. We have to understand this. Clear? Then what is m alpha by mp? Look into m alpha by mp is 4. It is 4. This is equal to root 4 into. Now what is charge of alpha? See, charge of alpha. What is alpha particle? Helium nucleus. Okay, which are the particles in helium nucleus? 2 protons and 2 neutrons. 2 protons are having 2e charge, positive 2e. Okay, the charge of a proton is E is equal to 1.6 into 10 power minus 19 coulomb. So charge of alpha, charge of alpha is 2e and charge of proton is E. 2e and E. Then what will be Q alpha by QP? That is 2. 2e by E is 2. 2. Okay, 2. Root of 4 into 2. Root of 4 into 2. What is root 4? 2. So this is 2 root 2. 2 root 2. 2 root 2. Okay. 2 root 2 is to 1. Isn't it? 2 root 2 is to 1. The answer is option C. Understand? Okay. Yes. The next one. Which of the following statements is incorrect about the photons? About the photons. See, momentum of photon is P by C. See, momentum of the photon is E by C. Actually, it is this one is energy by C. E by C. Okay, a small correction there. Momentum of the photon is E by C. That is true. Okay, energy. Energy of a photon is mc square, and what is energy mass relation is mc square, and what is E by C? E by C is mc square divided by C, which is mc mass into speed. That is momentum. Okay, yes. Rest mass of a photon is 0. Yes, rest mass of a photon is 0. Rest mass of a photon is 0. Okay, photon exerts no pressure is incorrect. Okay, photons, the radiations exerting pressure on the surface on which they are hitting. No pressure means incorrect. Okay, energy of photon is h nu, that is true. So the incorrect one is option C. Okay, the next. The wavelength of matter wave is independent of. Okay, what is the wavelength of matter wave is lambda is h divided by p de Broglie, h divided by mv. Okay, mass depends on velocity, depends on kinetic energy. Kinetic energy. Here it comes kinetic energy, instead of momentum. This is h divided by root of 2 mk. Kinetic energy also the term. Okay, it is independent of the charge. Okay, momentum of the particle is independent of the charge. So the answer is fourth one D. Okay. The next, which experiment best support the theory that matter has wave nature? Matter has wave nature. Matter has wave nature is supported by Davison and Germer experiment. Okay, for that they are awarded Nobel Prize. Okay, Davison and Germer experiments proved that electrons are having wave character. Electrons are having wave character. The important experiment in the history of the science. Okay. 11th, which among the following phenomena shows particle nature of light? Particle nature of light, photoelectric effect, interference, polarization, matter waves. All these are the wave nature, and the particle nature of radiation is understood by the phenomenon of photoelectric effect. So the answer is option A. Okay. Next, which of the following device is sometimes called electric eye? Okay, that is just a term. No need of worrying about it much. Electric eye, you just remember this one, photocell. Photocell, what is photocell? The conversion of radiation energy into electric energy. Radiation energy into electric energy is photocell. Okay. Then 13th, for a certain metal, okay, incident frequency nu, it is nu. Okay, it is nu. You take it as nu, is 5 times of the threshold frequency nu naught. 5 times of the threshold frequency nu naught. And maximum speed of coming out photoelectron is 8 into 10 power 6 meter per second. See, we have Kmax, the Einstein's famous photoelectric equation is the maximum kinetic energy of the photoelectrons emitted from the metallic surface, Kmax, is equal to the energy of the incidenting radiation minus the work function. Work function means h nu naught, where nu naught is the threshold frequency. This is very well famous Einstein's equation for which he was awarded Nobel Prize. Okay. Now here, when this frequency is 5 times of nu naught, then the maximum speed, so this one we can convert into speed, half into mass of electron into V max square. V max square is the maximum speed of the photoelectron, is equal to h nu minus h nu naught. Okay, this equation we can use. Okay. Now, in the first case, half into m into, I am taking V1. Okay. In the first case, V1 is equal to, when this frequency is 5 times, means 5 h nu minus h nu naught. 5 times of threshold frequency, 5 h nu naught. Okay. Understand? In the first case, frequency is 5 h nu naught, 5 nu naught. In the first case, this frequency is given as 5 times of the threshold frequency. So, h into 5 nu naught, h into 5 nu naught minus h nu naught. That is half into m into V1 square is equal to 4 h nu naught, equation number 1. Okay. Now, the second case, if frequency is twice of nu naught, what will be the maximum speed? Okay, in the second case, half into m into V2 square is equal to, the frequency twice of nu naught means twice of h nu naught minus h nu naught. You understood? Twice of h nu naught minus h nu naught. Clear? This is h nu naught. Okay. Half m V2 square is equal to h nu naught, equation number 2. Okay. V2 is asked. V2 is asked. Divide. Then half m cut. Okay. V2 by V1 all square. V2 square by V2 square by V1 square. V2 square by V1 square. That is V2 divided by V1 all square is equal to H nu naught divided by 4H nu naught. H nu naught divided by 4H nu. H nu naught cut 1 by 4. 1 by 4. Clear? Then take the square root. We get V2 is equal to 1 by 2 times of V1. Clear? V2 is equal to, take the square root, 1 by 4, square root is 1 by 2. V2 is equal to 1 by 2 times of V1. And V1 is, what is V1? 8 into 10 power 6. 8's half value is 4 into 10 power 6. 4 into 10 power 6 is the first option. Understood clearly? Okay? Yes. The next question is, an electron is moving with an initial velocity vector V. Vector V is equal to V naught into I cap. An electron is moving in the positive x direction, I cap. Understand? Yes. With a magnitude of velocity V naught. Okay. Yes. Enters into a uniform magnetic field vector B is equal to B naught J cap. Vector B is equal to what? B naught J cap. Okay. Means the electron is entering into a perpendicular field. Electron along positive x direction enters into perpendicular field which is directed along positive y direction. Okay, what happens? If a charged particle moves into a perpendicular field, then its motion becomes circular. Studied in moving charge and magnetism. The motion becomes circular. Motion of the electron becomes circular. Motion is now circular motion. Okay, circular motion with this is uniform circular motion. The electron is now in uniform circular motion with constant speed. Uniform circular motion means with constant speed. Okay, constant speed. Okay, velocity changing, because in circular motion the direction of velocity continuously changes, but the speed, that is the magnitude of velocity, remains constant. Okay, now what they ask, then it's de Broglie wavelength. What about de Broglie wavelength? Lambda is equal to h divided by mass into speed. H divided by mass into speed. H is not changing, mass is not changing, speed also not changing. So its de Broglie wavelength remains constant. Option C. Yes. Okay. The next question is number 15. For a wavelength of 400 nanometer, kinetic energy of emitted photoelectron is twice that for a wavelength of 600 nanometer. Okay. For a wavelength of 400 nanometer, the kinetic energy of the ejected electron is twice of the kinetic energy when the wavelength was 600 nanometer. This is Einstein's photoelectric equation. That is, the kinetic energy of the emitted electron is energy of incidenting radiation minus work function. Okay, here the work function of the metal is asked. This phi naught is asked, work function. Okay, now we know h nu is hc by lambda. The frequency is c by lambda. Okay, minus phi naught. Okay, this is the expression. Okay, when lambda is equal to 600, we use k. Then when lambda is equal to 400, we use twice of k. Okay, the kinetic energy is twice. Clear? That is, when we use k, here instead of lambda, we have to use 600. Nanometer we convert last. Minus phi naught. This is first equation. Then kinetic energy becomes twice when this lambda becomes 400 nanometer is given in the question, minus phi naught. This is equation number 2. Clear? And the question asked is, what is the work function phi naught? Okay. Then equation 2 divided by equation 1 gives. 2 divided by 1 gives, on LHS it becomes 2. 2 is equal to here hc by 400 minus phi naught divided by hc by 600 minus phi naught. Okay. Then 2 into this one, that is 2 into this one, hc by 600 minus phi naught is equal to HC by 400 minus phi naught. Clear? Multiply the terms with 2. 2 into HC by 600 is HC by 300. Okay. HC by 300 minus twice of phi naught is equal to HC divided by 400 minus phi naught. Clear? Minus phi naught to that side, then HC by 400 to this side. Okay. What we get? HC becomes common. Then what here? 300 is here. Then this one to this side means 1 by 400 minus 1 by 400 we get. 1 by 300 minus 1 by 400 is equal to, okay, here minus 2 phi naught to that side, that becomes plus 2 phi naught minus phi naught, that is phi naught. Okay, that is simply phi naught, and this is asked. Clear? It becomes HC into 400 minus 300, that is 100, divided by 400 into 300, that is 12 into then 10,000. 4 zeros. 2 zeros are cancelled. Okay, this is phi naught. Clear? Then it is HC divided by 1200 is equal to phi naught. Clear? Now remember, this is in nanometer unit, 1200. Clear? See, we have the expression of energy of a photon. Listen, energy of a photon as h nu, which is hc by lambda. Okay. Now, if lambda is given in nanometer or angstrom, suppose, it's very important. If lambda is in angstrom, suppose, then what will be this energy is equal to H is 6.626 into 10 power minus 34, C is 3 into 10 power 8 divided by lambda value in angstrom into angstrom converted into meter is 10 power minus 10. Now this much will be in joule unit. Okay, when we convert it into electron volt, usually the energy in this type of questions will be in electron volt unit. Okay, so this is in joule now. All these are in SI. Then the SI unit of energy is joule. So when we convert this into electron volt, we have to divide this by 1.6 into 10 power minus 19. Okay, now this much values, see, this much values are constants in all questions. Okay, and you remember this lambda is in which unit? In angstrom unit. For example, 5000 angstrom. Then you put 5000 here. The remaining are constants. Understand? Now this is equal to this one. This constant is equal to, when we solve this, we get 12423. This is very easy to remember. 12423 divided by the lambda in angstrom. The lambda value in which unit? Angstrom. Then your energy will be in which unit? Energy will be in electron volt unit. Energy will be in electron volt unit. Remember, in EV. This is very important. Okay. By using this expression, you can easily calculate energy in electron volt. 12423 divided by lambda in angstrom. Okay. And if you use lambda in nanometer, you divide this by 10. Divide this by 10. Your point will be here. 1242.3 divided by lambda in nanometer. Okay. Understand? I may write. There is this energy in electron volt unit is equal to 1242.3 divided by your lambda in which unit? Lambda in nanometer unit. These two things you keep in mind. Now in our question, this is in nanometer unit, 1200 nanometer unit. So what this value in electron volt? Phi naught in electron volt will be 12. So I am writing here. See, 1242.3 divided by which value? The nanometer value, that is 1200. Then our phi naught will be in which unit? Electron volt unit. That is the phi naught. Remember, this will be in electron volt unit. Understand? See, 1242.3 divided by 1200 is slightly greater than 1. 1.0 something. 1.0 something, and check the options here. 1.0 something is the answer of the question, option A. Understood? Clear? Okay. 16th. The linear momentum of a 3 mega electron volt photon is, linear momentum, you know, P is equal to mass into velocity. But here that of a photon is asked. Okay, the linear momentum of a photon is E divided by C, that is h nu by C. Okay, momentum E divided by C, that is h nu by C. Okay, yes. Then energy is given here 3 mega electron volt. 3 mega electron volt. And the options are in electron volt only. Okay, so this h nu is 3 mega. Mega is 10 power 6 electron volt. Okay, divided by C. C is, what is C? 3 into 10 power 8 meter per second. Clear? 3 cancel. 10 power 6 by 10 power 8 is 10 power 2 in the denominator. It is 10 power minus 2. So this is 10 power minus 2 electron volt meter inverse second in second. Second inverse to the numerator means second. Okay, second meter inverse. 10 power minus 2 is 1 by 100. That is 0.01 electron volt meter inverse second. 0.01 electron volt meter inverse second. 0.01 electron volt meter inverse second. Okay, yes. The next one. A particle of mass 4m at rest decays into two particles of masses m and 3m. Okay. The ratio of de Broglie wavelength of two particles will be. Here, there was a particle whose mass was 4m. Okay. It was at rest. That's the point. At rest means its initial momentum is 0. Now it decays into two particles. It is decaying into two particles. Okay, one having mass m1, the other having mass m2. This is moving with velocity v2, this is moving with velocity v1. Suppose. Okay, then we have to apply the conservation of linear momentum here to understand the idea of the velocities after the decay. Clear? See, since this decay process is purely due to some internal changes, no external force is applied. Okay, when the momentum will change? The momentum will change only when there is external force acting on the object or the system. But here, without any external force, it is simply decayed. Means the linear momentum will be conserved. You understand? Conservation of linear momentum. What it is read as? Conservation of linear momentum. Initial momentum of the system is equal to final momentum of the system. Initial momentum was 0. And final momentum, that is the momentum of first particle plus momentum of the second particle. Momenta, okay, of the two particles, vector quantities. Okay, momentum of first and momentum of second after the decay. These two terms are after the decay, which means the momentum of first after decay is minus of momentum of second after decay. Which means the momentum of this one and this one are in the opposite direction and equal in magnitude. Equal in magnitude and opposite in direction. Okay, the magnitude of this momentum is m1 v1 and that of this momentum having magnitude m2 v2. Okay, we can equate the magnitude. Direction is opposite indicated by the negative sign. Okay, while we write the magnitude, no need of negative sign there. Negative sign is to indicate the direction only here. Okay, so m1 v1 is equal to m2 v2. We understand this. Clear? Now, the two particles of mass m and 3m. Okay, see. One is having particle m. Suppose this is having particle m, then this will be having mass 3m. Okay, so m into v1 is equal to 3m into v2. M cancel, so v1 is equal to 3 times of v2. v1 is equal to 3 times of v2. Okay, the smaller fragment moves faster. v1 is the velocity or speed of the smaller fragment whose mass is m. that is equal to 3 times of V2. Okay, in order to equate the momentum values, that is mass into velocity is a constant, means if mass is less, velocity will be greater. Yes, okay. So this is the connection between their speeds. Now the question will be about de Broglie wavelength. The ratio of de Broglie wavelength of the two particles will be, we know de Broglie wavelength is inversely proportional to momentum. Okay, and momentum will be same. See, momentum after decay process will be same. M1 V1 is equal to M2 V2. Understand? De Broglie wavelength lambda is equal to h by p. You know, lambda is equal to h by p. Lambda is equal to h by p. But after the decay process, p value same for both. Understand? Then this will be 1:1. 1:1. De Broglie wavelength will be 1:1. Okay, speed will be different, mass is different such that momentum is same. So de Broglie wavelength will be same for both particles. I hope you understood it very clearly. Okay, then moving to the next one, the 18th one. In a photon particle collision, means a radiation hitting on the metallic surface is an example of photon particle collision. Okay, such as photon electron emission, that is photoelectric effect. Photoelectric effect. Yes. Which of the following may not be conserved? Which of the following may not be conserved? Energy will be conserved. Okay. Number of photons may not be conserved. Total momentum will be conserved. So, number of photons may not be conserved is the answer of the question 18th. Is 2, means option B is the answer of the question. Okay, some of the photons may be lost, the number of photons, okay, number of photons may not be conserved. The next question, number 19th, if the momentum of an electron is changed by P, momentum of the electron is changed by P, see, then the de Broglie wavelength associated with it changes by 0.5%. Okay, the initial momentum of the electron will be, we know the de Broglie wavelength lambda is equal to h by p. Clear? And the change in wavelength is very small, 0.5%. Then we can follow the method of differentiation in that way, because since the change is very, very small. Okay, then this means that this lambda is directly proportional to p raised to minus 1. P raised to minus 1. Okay, then the change d lambda is proportional to minus 1 into change of momentum dp. Means minus dp. That is the d lambda proportional to minus dp. Means as momentum increases, wavelength decreases because inversely proportional. Okay, that's this negative sign indicating, okay, these two changes are in the opposite sense. Okay, then when we take the magnitude only, we can neglect this negative sign. Means the magnitude of change of lambda is proportional to the magnitude of change of momentum. Okay, now in the question saying that wavelength changes by 0.5% when momentum changed by p. Clear? Yes. Then here we can do that, this d lambda by lambda. See, lambda, see, d lambda by lambda. D lambda by lambda is equal to dp by p, which is equal to dp divided by p. D lambda by lambda is equal to dp by p, since d lambda proportional to dp. Clear? Okay. Then d lambda by lambda is given 0.5%. 0.5% means 0.005. 0.5 divided by 100. Okay, 0.005 is equal to the change in momentum given in the question is P. Change in momentum given in the question is P divided by, this one is the initial momentum. This one is the initial momentum. We can write Pi, the initial momentum Pi. Simple. Then what is Pi is equal to? Pi is equal to P divided by 0.005. Okay. Multiply with 1000. 1000 by 1000. 1000 divided by 1000. See, this one here, when we multiply here into 1000 and here into 1000, then it becomes 1000 by 5, isn't it? Then it is equal to 200 times of P, isn't it? 200 times of P. 200 times of P, option A. Understand? Very clear? Okay. The phenomena of photoelectric effect was first explained by Albert Einstein. The phenomena first explained by Albert Einstein. All the questions were very simple. Okay, study well. See you soon. Thank you.